Hello students, welcome. How are you? Welcome to the PW Gulf channel. Today we are going to revise the chapter Permutations and Combinations. It's a very interesting logical chapter. If you guys enjoy it, that means your thinking power, logical power is really strong. And if you guys do not enjoy it, then take it as a challenge and give your best shot. Guys, only three things are there in this chapter. Very first thing, fundamental principle of counting, which will involve two types of fundamental principle, multiplication and addition. The second part is all about permutations, three types of permutations, and combination, only one type of combination, and some special case like rank of a word, block method, gap method. These miscellaneous things will also be covered in today's class. Well, this chapter, class 11th, we cannot actually define the weightage because every school, every college has a different weightage and the teachers make the paper. But what I can say is this chapter will be important for your next chapter probability. Not next, but yeah. Whenever you study probability, it will be important there. Even in class 12th, you have a chapter probability where a lot of permutations, combinations is used. Not just that, a chapter binomial theorem. Next chapter binomial theorem will also involve combinations in it. So yeah, traces of this present almost everywhere. You can find a lot of questions in JEE dependent on the knowledge of permutations and combinations. So knowing this chapter is going to really help you all a lot. Let's begin. The fundamental principle of counting. Okay. So suppose my dear bacha log, there are any event can occur in m different ways, following which another event in n different ways, and furthermore the third event in p ways. First event m ways, second event n ways, third event p ways. So the total number of ways of simultaneous occurrence of all the events is m into n into p. In how many ways can all of them occur simultaneously? It's m into n into p. That's your fundamental principle of multiplication. Whenever you want to identify whether they are happening simultaneously or not, multiply them. Another example, if you're leaving your home, घर से निकल के कुछ दूर चल के ऑटो पकड़ा और ऑटो के बाद सीधे सीधे अपने कॉलेज पहुंच गए ना. ड्रीम yes. So home, auto, college. From home to auto you can go in two ways. From auto to college you can go by three ways: walking, or running, or flying, whatever. So in how many ways can I reach from home to college? In total, how many ways can I reach from home to college? So will we add them like 2 plus 3, 5, or we will multiply them? Of course, we are going to multiply them. 2 into 3, 6. These are the total number of ways. If you want, you can also count 1A, 1B, 1C. 3 ways. 2A, 2B, 2C. Another 3 ways. So total 6 ways. Every time it's not possible for us to count manually. And that's why your fundamental principle of multiplication comes into picture. Simply multiply the two events. Event 1, home to auto, can occur in 2 ways. Event 2, auto to college, can occur in 3 ways. I want to know that the two events are dependent. I want to know in how many ways home to college. So home to auto, auto to college are dependent simultaneously. So 6 ways is the answer. Well guys, there is also another fundamental principle called as the fundamental principle of addition. We don't use that a lot, but yeah, it is important. Fundamental principle of addition. Fundamental principle of addition is used when the events are not dependent on each other or does not happen simultaneously. I'll give you two keywords. I will give you two keywords to solve questions whenever you get confused. When to do multiplication? Whenever there is a word and both, we do multiplication. And if you see event A and event B happening and multiply. Event A or event B happening, or if you see the word or, you will go for addition plus M plus N plus P, M plus N plus P, or it's your union. Also, whenever you have cases, very important guys, whenever you have cases in your question, case 1, case 2, case 3, that means you are going to add those cases, not multiply. Add case 1 plus case 2 plus case 3. How many cases depends on that. So cases is another hint for addition, fundamental principle of addition. Let's take a question on this. There are 3 routes from city A to city B and B to C there are, and 4 routes from B to C. Okay. Find the total number of ways a person can travel from A to C. Now, if a person has to travel from A to C, the person has to pass through B. There is no direct shortcut way, right? So, A, B, C all are dependent. Yeah, A is dependent on B, B dependent on C. Dependent events, 3 into 4. 3 ways into 4 ways, simply 12 ways are there in which a person can travel from A to C via B. Next, fundamental principle of multiplication. Let's try some more questions. In how many different ways can letters of the word knife be arranged? Now, have they talked about repetition, that you can repeat? K can be taken 5 times, 4 times, N can be taken 3 times? No. You just have to arrange these letters. So, 5 spaces, 1, 2, 3, 4, 5. The first space can be occupied in 5 ways. K, N, I, F, E. There are 5 options at this position. The next position will have only 4 options. 1 option is already gone. Out of 5, 1 gone. So 4 left. Next place will have only 3 choices. Followed by that 2 choices and 1 choice. And all of them I should multiply or add. I want to make a word. In order to make a word of 5 letters, all the 5 letters should come together. Only then a word will be formed. They all are dependent. They all are occurring simultaneously. And 5, 4, 3, 2, 1 is going to give me the answer as 120. Guys, this is your fundamental principle of multiplication. Okay, next question. Now again, repetition, not repetition. First case, repetition is allowed. Second case, repetition is not allowed. But what is the question? A 3-digit number is to be formed from 1, 2, 3, 4, 5. So out of this 5 numbers, we have to form 3-digit numbers. First case, when repetition is allowed. Okay. And second case, not allowed. We just saw a question on not allowed. So let me do a question of not allowed first. And then we'll go to allowed part. Color, which color you want? Chalo, not allowed. I want 3-digit number, 3 spaces from the 5. Here 5 choices, 4 choices, 3 choices. The number of choices keep on reducing. Why? Because repetition is not allowed. So if 1 letter is gone, 4 left. 1 more gone, 3 left. 5 into 4, 20 into 3, 60 digits can be formed. 60 digits, 60 numbers can be formed. But if repetition is allowed, my dear boys and girls, my kiddos, the first position has 5 choices. Now you will not reduce because the next position also has 5 and 5 choices. 5 cube 125 is the answer. 5 cube 125. 5 options, 5 options, 5 options. Are you able to understand very well? Right. So what we did just now, 5 into 4 into 3 in the previous question into 2 into 1, this is nothing but your factorial. So in general, n factorial is n into n minus 1 into n minus 2 into n minus 3 up till 1. The last term should be 1. That's your factorial. Okay. So if I ask you in general 7 factorial, you will say 7 into 6 into 5 into 4 into 3 into 2 into 1. And then calculate, multiply all of them, 5040. So by hearting this factorial is very helpful because in this previous question, instead of 5 into 4 into 3 into 2 into 1, it is nothing but 5 factorial, whose value we should by heart equal to 120. That also gives me a important information that n different objects can be arranged at n places in n factorial ways. If there are 5 objects and you want to arrange the 5 objects at 5 places, it can be done in 5 factorial ways. Check. If there are 5, if there are 1, 2, 3, 4, 5, 5 places and same number, 5 objects. So 5, 4, 3, 2, 1. In how many ways can it be done? Without this, we should be directly saying 5 factorial ways. If there are 7 objects, then 7, 6, 5, 4, 3, 2, 1, it can be done in 7 factorial ways. So n objects, n places, in how many ways can you arrange? N factorial ways. Let's talk about this factorials very well. You need to all remember this. ठीक है, अभी तक अगर नहीं किया है तुमने याद तो बड़ी बदमाशी कर रहे हो, अच्छे से कर लो याद बेटा, है ना. करना तो है आज, नहीं तो कल करना ही है, तो why not do it today, man. 0 factorial is 1, remember the very first thing, and rest of the things you can see. 3 factorial 3 to 1, 4 factorial 4 into 3 into 2 into 1, 5 factorial 5 into 4 into 3 into 2 into 1. Can I write 5 factorial as 5 into 4 factorial, because when you open this, one and the same. Similarly, 7 factorial 7 into previous factorial. So if you know 6 factorial, 720 into 7, you will get 5040. 40,320, 3,62,880, and just put one more 0 to get 10 factorial. I assume that you all will be by hearting this entire factorial series. Is 3 factorial plus 4 factorial equal to 7 factorial? That means, can I take this factorial common and add 3 plus 4, 7? No, this is not possible, because if you calculate separately the LHS, 3 factorial is 6, 4 factorial is 24, I am getting the answer 30. When you calculate RHS, 7 factorial is equal to 5040. Are they equal? Yeah, far away. So you cannot do such a thing. Okay, you cannot take factorial common. Let's move on to the next part. We have done with fundamental principle and arrangement, and fundamental principle as well as what? Factorials. Now let's move to the permutations, which means arrangement, and I am giving you this example. Remember this example whenever you get confused between combination or permutation. ठीक है, combination or permutation. Select means you will go for combination, arrange means you will go for permutation. Now remember, understand this example very well. I have 4 letters A, B, C, D. If the question is select 3 letters out of it, select ABC, ABD, ACD, BCD. Only 4 ways are there. You think just select 3 letters at a time. How many ways can you do that? Everyone can think, pause and think. There are only 4 ways, right? Okay. But if the question is arrange 3 letters out of 4, arrange 3 letters out of the given 4 letters. So I will not just select 3 letters, but I will also arrange among themselves. ABC will become ACB, BAC, BCA, CAB, CBA. Similarly, ABD will become ADB, BDA, BAD, DBA, DAB. So each of the selection is further arranging also amongst themselves, and that is what I mean by permutation. So here total of 4 ways I am getting. Whereas here, this 5 plus 1, 6, 6 plus 6 plus 6 plus 6, total of 24 ways I am getting. So selection will always be less, arrangement will always be more, isn't it? Obvious, of course. So select, arrange. When you want the letters to also arrange. Like if I am saying that select a class monitor, select 2 class monitor from your classroom. So will you use selection or arrangement? Will you go for combination or permutation thing? I want to pick 2 class monitors. Of course, I will go for selection because I want to just pick them. I don't want to arrange. Acha, Natasha and Rishabh is one option. Rishabh and Natasha is another option. Are they 2 different options? Rishabh, Natasha, Natasha, Rishabh. Are they same option or different option? They are the same option. So why will I arrange them? I don't need to arrange. I just need to select. Pick 2 monitors. We will go for combination. Like that, in every question you have to ask what they want to get from us. Okay. I already talked about this n lectures, n factorial ways. These are some of the properties which you should be noting down directly. NP, n minus 1, n minus 2, 1. NP0 is 1, NP1 is n, NPn minus 1 is n factorial. Remember this. And now, here is the, okay, for example, number of ways of arranging n different things at n different places is n factorial. In how many different words can letters of the word knife be arranged? So it has 5 letters can be arranged in 5 factorial ways. This is your very first type of permutation. There are 3 types of permutation. First type, when n different objects are there, different objects, remember, and you're selecting and arranging r at a time. So your n objects taking r at a time, formula is npr, n factorial upon n minus r, the whole factor. Its properties we have already written here, so please remember them. Just put r0, you will get 1. Put r1, you will get n. Put r as n minus 1 in the formula of npr, which is n factorial upon n minus r. The put r0, you will get, put r as 1, so you will get so on. Okay. Here is a question on first. How many 4-letter words can be formed using letters of the word education if using each letter at most 1? At most once means what? Each letter should be used maximum once. You cannot use it twice. That means it's a case of no repetition. So mind it guys, the first one is a case of no repetition. This formula is only applicable when there is no repetition. This formula applicable only when there is no repetition. ठीक है, ठीक है. 4 letters, education, EDUCATION. 9 letters, anything alike, any letters are same, repeating. So there are 9 letters, out of which you have to take 4 letters. And you just have to take it, or you also have to arrange them. I want to know in how many ways they will arrange. How many 4-letter words can be formed? So EDUC, one word. EUDC, another word. ECUD, I mean this 4 letters, if I keep on shuffling them here and there, new words will keep on forming. So shuffling is important to form new words. That's why we will go for permutation. 9p4. 9 factorial upon 9 minus 4, the whole factorial. 9 into 9 minus 4 will be how much? 5. So 9 into 8 into 7 into 6 into 5 factorial. And how much is 9 into 8 into 7 into 6? I think you guys will do it right. देखो भाई, इतनी तो करनी पड़ेगी. Or if you want, you can directly substitute the value of 9 factorial as 3,60,880 divided by 120. Whatever, the answer should be 302. Now just tell me one thing, one common sense. If I say NPR is this, isn't it obvious R should be between 0 and N? From 5 letters, you are taking out 3 letters. So N will be always greater, R will be always less or equal. R cannot be negative. You cannot say that, okay, out of 5 objects, arrange minus 2 objects? No, not possible. Negative number r cannot be negative, so greater than equal to 0. Okay, can we say that out of five objects you arrange 10 objects? How is that possible? There are only 5 available. How can I arrange 10? So r has to be less than equal to 9. Remember this small things, but very important. How many words with or without meaning can be formed from letters of the word mandu? Assuming that no letter is repeated. No letter repeated, type 1 permutation. If 4 letters are used at a time. Okay. So firstly, Monday has 6 letters. In how many ways can the letters of the word Monday arrange to give us different words? So Monday has 6 letters. It can arrange in 6 factorial ways. That is 620 words can be formed. First question, how many words with or without meaning can be formed from Monday? 720 words can be formed. Now coming to the first question. 4 letters are used at a time. 6p4. 6 factorial upon 6 minus 4, 2 factorial. 6 factorial is 720 by 2, 360 words. है ना? If 4 letters are used, 360 words can be formed. Second, all letters are used. Monday has 6 letters, all 6 letters are used. We said that n objects can be arranged in n factorial ways at n places. So if 6 objects you have to arrange at 6 places, it will be 6 factorial, that is 720 words. And all letters are used, but first letter is a vowel. Mandu has how many vowels? O, A, that's it. 2 vowel. 1, 2, 3, 4. Now you'll have to use this dash now. Or you can also, there is other way also, I'll tell you. Okay, first letter is a vowel. Matlab first letter can be either A or O. है ना? First space has 2 choices. Remaining 4 spaces, out of 6, 1 letter is gone. Out of 6, 1 vowel is gone. So 5 letters still left, 4 letters, 3 letters, 2 letters. And how much is this giving us? 5, 4, 3, 2, 1 is your 120 into 2, 240. 240. Understood? The other way of thinking it can be like this, the first letter is a vowel. The vowel can be decided in 2 ways, A or O. The remaining 5 places, Monday has 6 places, first place is gone. Remaining 5 place has how many choices? Sorry. The remaining 5 letters has to be arranged in how many places here? Sorry, 1 second. Sorry, 6, P, 5, is it? No. 1 second. Yeah, 5p5 yaar, 5p5. Matlab, the first space is gone. Now total of 5 spaces are left. There is one also here. Total 5 spaces are left and 5 letters are left. Out of 6, 5 spaces, 5 letters. So 2 into 5 factorial, that's 240. Or 2 into, out of 5, you're selecting and arranging 5. This is also equal to 250. How much is NPN? NPN is equal to n factorial. Do you remember that property? Very good. Next question. Find the value of R if 4PR, okay, if 5 times 4PR, 4 factorial upon 4 minus R the whole factorial is equal to 6 times 5 factorial upon 5 minus R minus 1 the whole factorial. Be careful with this brackets. Okay, now 5 into 4 factorial. Can I write 5 into 4 factorial as 5 factorial? Up, equal to 6 into 5 factorial divided by, let me open this, 5 minus R, minus of minus plus 1. Okay. Now this 5 factorial will be cancelled. We have 1 upon 4 minus R and 6 upon 5 plus 1, 6 minus r factorial 4 minus. Guys, which one is bigger, 4 minus r or 6 minus r? Of course, 6 minus r is bigger. So you will expand, you will open up the bigger term. You will split the bigger term always. 1 upon 4 minus r the whole factorial is equal to upon, keep on reducing one term. So 6 minus r, then 6 minus r minus 1, 5 minus r, 6, 5 minus r minus 1, 4 minus r, stop. Why stop? So that we can cancel from left and right. Rearranging it, 6 minus r into 5 minus r is equal to 6. See, there are two approaches to solve this question. One is you open simply 6 5s are 30 minus 6r minus 5r and minus of minus plus r square. Then you come make it a nice quadratic equation. R square, yeah, equal to 6 is also that, right? R square minus 6 minus 5 minus 11r plus 30 minus 6 equal to 0. R square minus 11r, 30 minus 6 will be 24 equal to 0. Then you factorize it and you will get some value of r, probably two values of r. That's one way. Other way you can think is, what are the two numbers, what are the two consecutive numbers which on multiplication will give me 6? Because this is consecutive, isn't it? 6 minus r, 5 minus r. They're like just side by side. Two numbers which are side by side. 6 minus r is bigger one, 5 minus r is smaller one. So yes, you all got it correct. 3 into 2 is 6. They are consecutive numbers. You will say, ma'am, 6 ones are 6. But 6 and 1 are not consecutive. So 3 into 2, this 3 is equal to 6 minus r. R can be equal to 3. Or you can also compare 5 minus r equal to 2. R again comes out to be equal to 3. So I think when you solve this, you will get a value of r to be equal to 3. The value of r is 3. 4p3 equal to 6 times 5p, 3 minus 1. Question solved. Second type of permutation is the permutation when there are m objects given to you and out of them p are alike. P are alike. That is hoo-bahoo, hum shakal, same to same. I'm not talking about when objects are repeated. No, I'm talking about when objects look same. In such a case, how many different ways are there? M factorial upon p factorial. That is total number of objects divided by objects which are alike. You will always divide the alike objects. Total number of objects divided by objects which are alike. Always. Hoo-bahoo. If you want, yeah, there is an example. Mommy. Mummy. Mommy is the number saved. Okay. M-U-M-M-Y. 6 letters. So this M value is equal to 6. How many of them are alike? Value of P 1, 2, 3. Are 3 objects are hoo-bahoo, hum shakal. P is 3. In how many ways can you arrange them, or how many words can be formed by arranging mummy? 6 factorial upon 3 factorial. That's 720 by 6. 60. 60 words can be formed by arranging letters of the word mummy, because this M, M, M are same. So whatever is same, divide. I mean, if you want to understand what they are actually saying, if you do not divide, you are counting each of them as different. This mummy is different, then M1, M2 and M3 interchange, it's another mummy. Then M2, M1 interchange, another mummy. But actually they are not, they are all the same words. Even if you arrange the M, they are all the same words. They are not different. So we don't want to count them different. So we are dividing 3 letters same, divide by 3. 1 minute. Mum, M-U-M-M-Y. Why did I take 6 factorial? Because I am the smartest. You guys are the best. 5 factorial is 120 by 6. होता है यार, मेरे से तो बहुत होता है ये, क्या करें. And now let's say you have total these many objects, m plus n plus p. Let's say total 10 objects. m plus n plus p, out of which 3 are alike, 2 are alike, 2 are alike. है ना? Like there are 3 m's, 3 p's and 3 n. So in how many ways can you do this arrangement? 10 factorial upon जो भी सेम सेम है यार, हम शक्ल्स को डिवाइड कर दो. 3 m's repeating and in same divide. 2p same divide. 2n alike divide. Alike and different. Different means different. Distinct. Alike means same. So that's how it will work. It's the same. Type 2 permutation. हम शक्ल्स. Type 3 permutation is when repetition allowed. Guys. Type 1 repetition not allowed, type 3 repetition allowed, and in that case, if there are n objects you are taking r at a time, the formula becomes n raised to r. For example, I have 4 letters rows and I want to make 3-letter word, giving the repetition freedom. So first space will have 4 choices. How many number of letters? 4. How many I have to select and arrange? 3. So out of 4, 3 taken at a time. Out of 4 letters, I am trying to form 3-letter word. So first position has 4 choices. Now repetition is allowed. So second also 4, third also 4. It's all 4 cube. Isn't it n raised to r? Type 3 permutation. Okay. Chaliye. Next we move to block and gap method. Block method is when 2 objects are always together. You want to hold them together. For example, we have 7 students watching this session. Wow, such a less figure. Yes, because you guys do not share it. That's why. Suppose we have 7 students in which 4 girls and 3 boys are there. 4 plus 3, 7. And we all decide to go and study in the library. Okay, I take you all to the library. Now this time not taking you to the movie. Every time I take my students to the movie in this example. So but now library mein hum ja rahe hain, and library mein what I want is all the boys should sit together. Why the boys should sit together? Because I can then notice them. I can pay attention on them. If any one of them is doing any mischief, I will throw all of them out. If boys are sitting separately, it will be very difficult for me to manage everyone. And my attention will be diverted. So not to divert my attention, I want the boys to sit together. So because I want all the boys, 3 boys to be together, what we will do is B1, B2, B3. Let's say these are the 3 boys. We will bundle them. We will tie them together. We will block them together. It is also called as your bundle method. Okay, we will tie them together. So these 3 boys are not actually 3 boys for me. For me, there's only one object, one boy. I just have to pay attention at one object and I'm done. So these 3 boys are counted as one object, whereas the remaining 4 girls will be counted as 4 objects. So 4 girls and 1 gang is equal to 5 objects. 5 objects can arrange among themselves. They can arrange among themselves in 5 factorial ways. Well, these 3 boys will also arrange. Do you agree? They are not going to keep quiet. Like they will keep arranging amongst themselves. B1 comes here, B3 comes there, B2 comes here. They will keep shuffling amongst themselves. So these 3 objects will arrange in 3 factorial ways. The total of 120 into 6, 12, 6, that's 720 ways in which this 4 girls, 3 boys can sit in a library such that boys are always together. And just the opposite case. Now, let's say I want to go and eat tiffin in the canteen. I'm hungry now. I want to leave the library. Because I want to leave the library, I want to ensure that the boys don't make any noise. How will that happen? Now, I want a case where no 2 objects are together. That is, no 2 boys are together. Same scenario. 7 students, 4 girls, 3 boys. I want no 2 boys to be together. The objects here are now boys. I want that the boys should always be separated. That is If two boys come together, there's some mischief, है ना? Lot of judgment. Yeah, boys, my boys are very good. I love my boys, but boys, क्या करें यार? गर्ल्स को बोलेंगे तो सही नहीं लगता ना. सह लेंगे. No two boys are together. If I want such a scenario, firstly, we will arrange the girls. The one who doesn't have any restriction can go and arrange among themselves the way they want. 4 girls can arrange the way they want. They have no restriction. Boys have restriction. Girls don't have. So allow the girls to arrange in 4 factorial ways, man. The girls will arrange in 4 factorial ways. Well, because I want the boys to be never together, the 3 boys can occupy these spaces. See na, either boy can sit here or here or here or here or here. This will ensure that the 2 x's are never together. The 2 boys are never together. If I place the boys in this position. So how many x? 1, 2, 3, 4, 5. 5x, but there are only 3 boys. So out of 5, we have to select 3 places for my 3 boys, and the boys will also arrange. So 5p3. If it's selection, then 5c3, but the boys are not going to keep quiet. b1, b2, b3. Then they will arrange also. So arrangement, that's why P, permutation. If it is combination, that is, they are not going to arrange. Let's say there is a scene where they're not allowed to move, then we will use combination. 4 factorial, your 24 into 5 factorial upon 5 minus 3 is how much? 2 factorial. 2 ones are 2 12s are 5 factorial is 120 into 12, 1440 ways. Oh my god. There are so many ways in which I can make all of you sit, ensuring that boys are not together. So you think that teacher doesn't have any way? Teacher has 1440 ways to ensure no 2 boys are together. But we don't use it here. We don't use a super. Alright, let's do a question. There are 5 girls, 5 boys. In how many ways they can be seated in a row such that no 2 girls are together? See, am I fair? Am I not fair? I am fair. Now the girls are not allowed to sit together. If girls are not allowed to sit together, boys can sit together. Give the freedom to boys. Let the boys run and occupy any of the 5 places. So 5 boys will arrange themselves in 5 factorial ways. Guys, this is your gap method. No 2 girls are together, never together. So it's a gap method. Block means always together. So 5 boys in 5 factorial ways. Now the spaces will be arranged by the girls. The spaces will be occupied by the girls. 5 girls will occupy this 6 spaces in how many ways? 6p, 3 ways. Simplify, guys. You will have to simplify. हाँ ठीक है, कर लोगे ना खत्म? हाँ कि ना? कितना होता है ये? हमेशा 7 ही क्यों बोलते हैं? 12 6 720, 7200 ways. My. कुछ ज़्यादा ही तरीका नहीं हो गया? कुछ अनबिलीवेबल सा नहीं हो गया? हो तो गया है. Okay, next. And how many of the distinct permutation of letters in Mississippi do the 4 I's not come together? Now it's a very special and IMP question. Is it block method or gap method? It's neither. I'm saying the 4 I's should not come together. 3 I can come together. 2 I's can come together. All 4 should not come together. That's my concern. In the previous question, that is gap method, the concern was none of the girls should be together. No 2 girls should be together. No girls will be side by side. Here, 2I can be side by side. 3I can be side by side. I mean, we can have a case where we have 3I, then M, S, I, P, P, I. 3I can be together. 2I can be together. But all 4 I's cannot be together. I mean, don't take a case where you have all 4 I's together and then MSS, P, whatever. Don't take a case where all 4 of them are together. So that means all 4 should not be together. All 4 together is block method. This question is approached like this. Right? Number of ways in which all 4 I's are not together is equal to total number of permutations. Total number of permutations of the word Mississippi minus number of permutation with I always together. Remove from the total, you remove the all I together cases, you will get all I never together case. Okay, so total number of permutation, guys. First, let's explore the word Mississippi. M once, I is 1, 2, 3, 4 times. S is 1, 2, 3, 4 times. And then P is 2 times. 4, 5. Okay, 4, 4, 8, 10, 11. 1, 2, 3. 1, 2, 3, 6, 11. करेक्ट है बॉस, चल भाई, बड़ी गलती होती है, बड़े ध्यान से करना. Okay, total permutation, guys. How will you calculate the total permutation? Total permutation of arranging letters of the word Mississippi. Ma'am, there are 11 words, so 11 factorial. 11 words can arrange in 11 factorial ways? No. Alike objects should be divided. That is your 4 times I, 4 times S and 2 times P should be divided. That's total permutation. Next. 4 I's always together. Now I want the case where the 4 I's are always together. That is, block them here. Tie them in a bundle. If 4 I's are blocked together, remaining 4, 5, 6, 7 objects, this 1 plus 7, 8 objects will arrange in 8 factorial ways. Okay. Then this 7 objects in this remaining, forget the I, in this remaining 7 objects, 4 S is present, alike object should be divided, 2 P is present, divided. एक मिनट, 4S 2P और क्या भैया, ये तो 6 हुआ, 7 8 7 8, ठीक है. So this 8 objects will arrange in 8 factorial ways. Then in this 7 objects there are 4S and 2P repeating. In this I objects, will the 4I arrange in 4 factorial ways? Okay, if you arrange them, then all of them are alike, so divide also. So no need of arranging this 4I. No need of arranging it. Like in the previous case, the boys wanted to shuffle B1, B2, B3. They were shuffling. Here, will the shuffling make any sense? This I, all I are same. So shuffling doesn't make sense. So we will not multiply with 4 factorial. There is no shuffling happening. Because we are not counting, we are counting this as one object. There is no need to divide by 4 factorial because it's only one object in my eyes. It's not 4 I's. I will not divide with 4. It's only one object. If I arrange them, then yes, it is counted. But now it's not counted. Well, once you get the answers for both, all you have to do is divide 11 factorial upon 4 factorial, 4 factorial, 2 factorial, minus 8 upon 4 and 2. Once you solve, you all should be able to get the answer. And what's the answer, boys and girls? The answer is 33810. ठीक है, मैंने तो कर रखा है, मैं तो होशियार हूँ, तुम भी होशियार बन जाओ यार करके फटाफट. Let's go to the next and last part, selection. Not last, second last. Last is rank of word. Selection means combinations in which there are n objects and are taken at a time, are selecting at a time. NCR, n factorial upon n factorial, n factorial upon r factorial, n minus r the whole factorial. NCR, guys, is also written like this. This symbol, if you see somewhere, it is also a combination. Okay, NCR is equal to NPR upon R factorial, very similar to your permutation. Just write the formula of permutation and divide with R factorial. You will get NCR. NC0 and NC1 equal to 1. Please by heart it, next chapter binomial, you will need it. NC0, NCN1. In how many ways can you select 0 objects out of n? One way. In how many ways can you select all n objects out of n objects? There's only one way to select all the objects. NC1 is n. Very IMP. NCR is equal to NCN minus R, guys. Combination has this symmetric kind of palindrome kind of property, meaning if 10C6 will be equal to 10C, 10 minus 6, 4. So 10C6 and 10C4 will be equal. Similarly, 52C4, if I say, it will be equal to what? Either if I put a question mark. If I put a question mark, 52C4 will be equal to what? What is this value? So you will simply do 52 minus 4, which is 48. I say 52C4 is equal to 52C48. Third, that's fourth property. And last, NCR plus NCR plus 1. You will increase the power by 1 and plus 1. NCR plus NCR minus 1. Increase the power by 1. And from the base, you will pick the bigger one. You will pick the bigger one. Okay? That's a property. We are not getting into the proofs and all. Hope so. It's okay. So there are 4 people A, B, C, D. And you want to select 2 monitors from 4 monitors. From 4 shortlisted people, you are finally selecting the 2 monitors. In how many ways can that be done? 4C2. Right? Calculate, you will get the answer. Next. NC8 is NC2. Find the value of NC2. Guys, NC8 is equal to NC2. What does this tell me? The fourth property is going to be used. It simply tells me that n minus 8 or 8 is equal to n minus 2. This number will be the subtract. Or you can also say n minus 8 is equal to 2, 1 and the same. Therefore, n is equal to. Is the question find n? No. No. The question is find NC2. That's 10C2. That is 10 factorial upon 2 factorial, 10 minus 2, 8 factorial. 10 into 9 into 8 factorial on 2 into 8. 9 is the 45. The value of 10C2 or NC2 is 45. Question solved. I hope you all understood how this thing came into picture. Chaliye. There are n different points on a circle. Joining these points, how many straight lines can be formed? There are certain number of points. Basically, join the points and form the chords. And when you join any 2 points on a circle, basically you form a chord. N points are there. And you want to form straight lines, na? So for forming straight lines, you want 2 points. On a circle, 2 points will form a straight line. 3 points can form a straight line on a circle. If you join these, will it form a straight line? Like let's say this is another. Will it on joining form a straight line? No. So for forming a straight line, I need 2 points. Total n points are there, out of which I want to select 2 points. These two, these two, these two. Do I want to select and also arrange? Like this is one case, another case. P1, P2, 1. Then you want P1, then you will join P1 and P3. Then you will join P2 and P3. You just want to select the points, 2 points to make a line, or you want to also arrange them. P2, P1, P3, P1, P3, P1. Are they giving me new lines? No. Arranging will not give me new lines. I just want to count the total number of lines. So selection is the way out, guys. N factorial upon n minus 2 the whole factorial into 2 factorial. If they say similar questions appear in your textbook, find the number of triangles that can be formed. The total number of points. And for making a triangle, you need 3 points to be joined. So NC3 will come. If it's a chord, NC2. Chord is straight line. Find the number of ways in which 9 balls from 6 red balls, 5 white balls and 5 blue balls. ठीक है, 6 red balls. अभी white, 5 white balls and 5 blue. ये तो बहुत dark है. 5 blue balls. है ना? You want to select, guys, selection combination. Selection of 9 balls out of this lot. And each selection consists of 3 balls of each color. That is 3 red, 3 white and 3 blue. I want to select 3 red. So 6C3. I also want to select 3 white, 5C3 and 3 blue, 5C. White, blue. Should I add them, multiply them? Total I want 9 balls. Do I want 3 balls? If it was find 3 balls, then I would have added. But total 9 balls. This. All of them depend on each other. And hence we will multiply and get the answer. ठीक है, पक्का पक्का सॉल्व कर लोगे? नहीं? कौन बोल रहा है ये नहीं? हाँ? 5 factorial upon 3 factorial, 2 factorial, 5 factorial. 6 factorial is 720. Upon 3 factorial is 6 6 are 36. 5 factorial 120 upon 6 are 12. Same thing. Isn't it? 12 cancel. 36 ones are 36 twos are 20 and then 2 more zeros. There are 2000 ways to make this happen. Will you make it happen, my bachcha log? Pakka pakka pakka. 101 चक्का. Very good यार, very good. चलो ना फिर. किसका है ये तुमको इंतजार? कार्ड प्रॉब्लम तो बनता है ना यार. Whenever you're doing permutation, combination or probability, card problem is like must. There are in a deck of 52 cards. If there is exactly one ace in each combination, determine the number of 5 card combination out of a deck of 2 cards. ठीक है, if there is exactly one ace in each combination, that means you're choosing 5 cards. ठीक है, out of 52 you're choosing 5 cards. One of them is going to be ace. One card is definitely ace. So total of how many ace cards you have in 52? In 52 we have 4 ace cards. From 4 ace cards we will select one ace card, and from the remaining 48 non-ace cards, we will select the remaining 4 cards. So total 1 and 4, 5 cards, 1 ace card and 4 remaining cards. 1 and 4, 5. So 1 and 4 together will make it 5. They are simultaneous, dependent, multiply. 4C1 will be 4. And this is 48 factorial upon 4 factorial. 48 minus 4, 44 factorial. You can proceed with the calculation and get the answer. I will go to the last part, which is rank of a word. Hope you have already studied, so just a quick revision to make it understand if you have forgotten. Rank of a word is nothing but when you arrange all letters of a given word in the order of dictionary. Try to recall the old times Oxford Dictionary, Merriam Dictionary and etc., which we used to have, our parents used to have at home in order to search any word. So if they ask you a question, arrange letters of the word Varsha. I always like to take my example because it is long, so you understand by the time I finish. It has 2 objects alike. It also covers the case of alikeness. Okay. Varsha. Arrange the letters of the word Varsha and find what will be rank of the word Varsha. When you arrange them, Varsha will come at which position when you arrange all the letters. So of course A has the least priority. A is least priority, or I should say most priority, like your functional group in chemistry. A has the most priority, then A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. Is the priority deciding correct? The alphabetical order? Alright, that means all the names will start with first A. Varsha is 6 letter, so first letter fixed to A. Remaining 5 spaces can be filled in 5 factorial ways. Remaining 5 spaces. Remember, there are two times A in the. Okay, so first letter is A. Remaining 5 letters can be arranged in 5 factorial ways, which is 120 words can be formed with the letter A. After A, priority में क्या आता है? H. 1, 2, 3, 4, 5. If H is fixed, remaining 5 letters can arrange in 5 factorial ways. But mind it, these 5 places will also have 2A in them. This 5 arrangement will have 2A divided by 2 factorial. Earlier, this 5 didn't have any A, so no need of dividing. After H, we have R. 1, 2, 3, 4. Again, this 5 places, 5 factorial, 2A, 60 words can be formed. After H, after R, 3, fourth position is S. Same. 5 factorial ways. Are you able to understand? 60 words can be formed using starting with S. The moment you find a letter which you want, block it. हाँ, अभी हमको after S automatically V will come, isn't it? And we want, block it. From after V automatically A will come. Do you want A? Yes, for making Varsha we need A. Block it. After A automatically the next A will come. Do we want this A? Varsha. Varsha. We don't want this A. So find out how many letters starting with Va will appear. So these 3 places can be arranged in 3 factorial ways, that is 6 words. Then V and A is already fixed, huh? You don't have to touch them. After A, priority wise H will come. Do you want H? No. Find out how many words can be formed with Va. 3 factorial. Then VA is fixed. After H, third priority is R. Do you want R? Yes, block it. After R, then once again priority starts. A will come. Do you want A? No. Find out number of words starting with Vara. 2 words. And VAR is already blocked. After A, in the priority there is one more A which is already used. H. Do we want H? No. Find number of words starting with Var. 2 words. Then after VAR, H. After H, you will get S. Do you want S? Block it na. So blocked. Once you block the number, start the priority again. Next letter will be A. Do we want A? So VRS A. Varsa. Do we want Varsa? No. So there is one word with this Varsa. And then finally VRS is blocked. After A, the priority will go to H and automatically this will become A. So this is your word. Okay. What is the position of this word? 120 plus 60, 120, 240, 300, 312, 314, 316, 370. This is at 318th position. What is rank of the word Varsha? The rank of the word Varsha is 318. Please check it for your names also. If it's a very big name, all the very best to you in advance. So summary, yes, we did finally the full chapter. Yeah, did you like it? If you liked it, please show some hearts in the comments and we will keep working for you, making more videos to make your life simple, to revise quickly and in most efficient way. Thank you so much. Bye-bye. Take care. Keep smiling.